This is part 2 of the Eiffel Tower series. If you haven't listened to part 1 yet, I would encourage you to do so as the episodes move in chronological order. In part 1, we discussed how a contest was held to design a grand entrance for the Paris World's Fair, and how the design for the Eiffel Tower was the victor. The foundation was laid, the iron beams arrived and were assembled, and the Eiffel Tower started to take shape. Let's jump into part 2, where the construction of the Eiffel Tower continues.
Hello, and welcome to the Spark History Show, where we bring history to light. Take a dive with us into history and hear the real accounts of the stories of the past as they actually unfolded. Explore with us as we shine some light on the amazing events that shaped our world into what we have today. We are going to recreate the stories of the past to better understand the struggles and triumphs during the most epic moments in history. This is the Spark History Show. Let us begin the journey.
In July of 1887, the metal ironwork of the tower started to flow out of the piers and upward at a 54-degree angle towards the center of where the tower would stand. As the height increased past the capabilities of the smaller ground-based cranes, the construction crew made use of steam-powered cranes that were built into the elevator shafts that were part of each leg of the tower. As the height of the tower grew, the cranes could continue up the elevator shaft that was being built around them to higher and higher points. The integrated cranes had a full 360-degree maneuverability and could lift up to 13 tons. This meant the workers could have the girders dropped just right where they were required for the rivet teams. They didn't have to shuffle around and fight with the crane operators to get the items where they were needed and then make the final adjustments themselves, as would normally be the case. The amount of iron that would be put into the tower was immense. Every month, nearly 400 tons of girders and trusses would be pulled by horse-drawn carriages from Eiffel's ironworks 3 miles away down to the construction site. There were also a large number of girders that would be used in this construction compared to other projects of the day. Eiffel had decided to both prevent catastrophic accidents and also to streamline the manufacturing process. Smaller components would be used instead of the normal size girders, and then these smaller components would be linked together with rivets. This was instead of having smaller quantities of extremely large girders that were much more dangerous to hoist into place and also transport to the site. This also allowed the cranes to be of a smaller design and more nimble. All of these small girders did mean there was a lot of extra work for the rivet teams. Since each of the smaller beams had to be connected together, there were 20 rivet teams that were required to put in around 1,650 rivets per day. The final number of rivets on the tower would amount to a staggering 2.5 million. Luckily for the rivet teams, they would only have to complete a third of the rivets, as in the ironworks assembly process, Eiffel had instructed workers to complete the rest of the rivets that could be assembled off-site. Around 250 workmen each day toiled away building the tower. In construction standards, this was a low number of construction crew operating on such a large project. This ended up being offset by having many of the workers chosen for the job as veterans from Eiffel's company who had worked on a number of his other ironwork bridges and were familiar with the building process in iron. He brought his starting players to the site, his Praetorian Guard, his most seasoned troops. Every detail of the project's construction was known beforehand. There were no estimations or guesswork. When the height of the legs reaching upward at an angle before the first platform reached a height of 92 feet, the construction team knew that they would need additional support. In the design, it was calculated at exactly the point in height that the center of gravity from the angled legs would shift away from their base, and without the connecting platform, would cause the legs to buckle or topple over towards the ground. When the legs neared this height, The crew placed wooden pylon scaffolding 92 feet high up against the inclining legs to provide the required support. The date was now October 10th, 1887, and the tower had made significant progress to the point right before the connecting platform on the legs. The citizens of Paris started to take notice of the increasing height of the structure, staring up at it in the morning sun, seeing the shadow it casts across the ground. 98,000 rivets had been placed into the 10 tons of iron that had been assembled onto the structure. Some citizens near the location of the tower also began to get a little worried by the overbearing structure. What if this construction company didn't really know what they were doing? What if the skeptics are right and the tower would collapse? What if pieces of the construction fall off, damaging the nearby buildings? What if they fall on the children walking by? The children! Somebody think of the children! As you can see, things started to get a little crazy. At the height of these fears, a man actually started a lawsuit against the city of Paris, claiming that the tower might collapse onto the nearby residences and cause serious injury to people and property. During the time of the suit, the city ordered construction on the tower halted until a settlement could be reached. Eiffel was already pressed for time because the exposition committee had delayed so long before starting the project. And now there was this new legal entanglement. The tower had to be finished before the giant fair started, which would bring in people from numerous other countries. What good would the dramatic tower over the entrance of the fair be if it was still just a construction site when the fair opened? Eiffel had reviewed the designs himself and knew they were sound. Since the city did not want to pay in the event of any disaster, Eiffel decided to take it upon himself to end the legal showdown. Standing by his belief in the soundness of the design, Eiffel proposed that he would cover the cost of damages if any were caused by the construction, and also cover the full cost of demolition of the structure if it was deemed necessary if it posed too much of a danger to the surrounding neighborhoods of Paris. The suit reached a settlement, and the city was able to transfer the financial burden to Eiffel and his company. Most importantly for the project, work was able to once again continue on the tower. During the course of the construction, there would end up being no significant damages to nearby property. The tower continued to close in on the area where the first platform would be built. To make any adjustments that would be necessary, an interesting system was set up into the pylon support beams holding up the angled column legs of the tower. On the end of each one of the pylon scaffolding was both a hydraulic jack and a metal cylinder filled with sand on the bottom and a piston at the top. To make those last adjustments connecting the columns of the leg and the center platform at the correct height, these devices were used. The measurements needed to be within a fraction of an inch of the blueprints to ensure that everything locked together correctly when the legs met the middle platform. How could giant columns of iron that weighed literally tons of iron, 400 tons to be exact, be moved once they were already constructed? How could those fine adjustments be made? And that is the genius in the simplicity of design that Eiffel used with the hydraulic jacks and metal cylinders filled with sand and a piston that we spoke about earlier. If the legs were a little too low, the hydraulic jacks could be pumped to push the pistons in the metal cylinders and ever so slightly raise the column leg to the proper height. If the column was too high, then the small plug could be opened in the cylinder and gravity would allow the sand to slowly fall out, lowering the piston attached to the column ever so slightly and pulling it into the correct position. The plug could then be closed up where the sand was released, locking the height in the proper position, and alignment could be achieved. This is a very simple design that solves a complex issue. That was the brilliance of Eiffel. The height of the tower continued to raise, and now we are standing at around 180 feet of elevation. The next step is to connect the 4 angled piers of iron with horizontal trusses of iron to form the first platform. This was record time for this type of construction. At this rate, the project might actually be completed on time for the World's Fair. Citizens of Paris went about their normal day, gawking up at the structure. Every day, it would grow a little higher. You couldn't really stand and watch it grow, but yet every day or a few days when you looked back over at the structure, it would be higher than it had been before. How were they able to build it so fast? In the US, when we talk about production and assembly lines, a name that usually comes to the forefront is Henry Ford and Ford Motor Company. He led his company to design and mass produce the Ford Model T. It was essentially the first mass-market motor vehicle that was affordable for the working class. A few of the major factors in being able to mass-produce the car were the assembly line techniques of making standard mechanized parts instead of handmade custom ones, and having an assembly line to have cars rolling out of the factory as fast as possible. When Eiffel was building the tower, he had a much smaller crew than what would normally be seen at the time in a project of that size. Remember, there were only around 250 workmen on the tower each day. This is because each of the workmen had a very specific task that they were entrusted with. The materials that arrived on site were already prefabricated to the exact dimensions that were required, much the same way as Henry Ford had standard parts for use in his vehicles. On Ford's assembly line, when the car under construction came to the workman's post, he added in the parts that were under his role in the assembly. They fit right into place, and then the production moved on to the next station. On the tower, the men would receive the iron beam which was cut to the exact specifications at the ironworks. No additional modifications were required on site. The crane crew would hoist it to the correct location, and then the riveters would hammer the rivets in to hold it into place. Then they would move on to the next one. In this quick and efficient manner, due to the properly prefabricated beams, the 20 rivet crews that were operating could hammer in 1,650 rivets each and every day. If modifications to the beams had been needed to be made on the site of the tower, the speed would have been drastically reduced. In this way, Eiffel was able to use new construction techniques to help his project move along as smoothly as possible. The progress on the construction had been going well. The foundations were set and the angled piers grew ever higher into the sky. But now came a critical moment in the construction. It was time to connect the 4 legs of the tower into the first platform of the structure. In the year 1888, this was a new type of framework. Massive and heavy iron legs would have to be angled just right to connect into trusses between the piers that would hold them together and to each other. This first platform would also have to support the massive weight from the rest of the tower and distribute it evenly across the 4 legs. If the calculations were off or errors were made, the tower could end up leaning too much to one side and topple or crack and break. The iron trusses were delivered to the site and were raised into the position where they would be connected to the piers at a height of 150 feet. The massive horizontal trusses were 25 feet in depth and needed to be ever so carefully connected to the 16 columns coming from the 4 legs in each of the 4 iron beam frameworks comprising each pier. The crew positioned themselves to adjust the different piers to align with the holes already bored into the horizontal trusses. This is where the hydraulic jacks and cylinders with sand that Eiffel had implemented would come in handy. 4 workers positioned themselves on each pier. They were able to use so few men because of the system that had been set up. A couple of the pylons had to be slightly adjusted to get the trusses just right to line up all of the pre-drilled holes. 2 men would operate a water pump that would slowly use the force of water to jack up the section of the pier from the bottom. When it reached the correct height, Two other workmen would insert iron wedges into the additional space to hold it in place. If the piers were too high, workmen released some of the sand in the cylinders on the support pylons, letting the pier settle slightly lower. They would then reapply the plug, and it was set. Although it might sound like, oh man, if the architect was so good, why did they still have to adjust the piers in the first place? Well, keep in mind that these piers were a staggering 400 tons in weight and 150 feet off the ground, angled at a rate that would make them fall if not supported by pylons. They had to meet the trusses in midair at that height. There are a lot of factors such as errors on workmanship, or the weather, or design errors that could throw the piers off. Even with all of that, none of the piers ended up having to move more than 2.5 inches to be able to line up the rivet holes and lock the trusses into place. Have you ever tried to assemble IKEA furniture? Even those simple, well, seemingly simple cabinets, tables, and dressers that we put in modern homes require a little finagling to get all the pieces to fit right. If you ever put one together, you know the joke about how it can become a frustrating ordeal. In the case of the Eiffel Tower, they were doing that on a grand scale and with brand new construction techniques. I think we should give them a little leeway. With the trusses locked in place, the first platform took shape and connected all of the piers at the height of 150 feet. The most difficult task had been completed. With the platform in place, the weight for the rest of the tower would be more evenly distributed, and Eiffel would not have to worry about the angled sides of the tower caving in or causing a catastrophic accident. The strong foundation created by the first platform would allow much easier construction of the next 800 feet of the tower that was to bear its weight down on the top of the platform. On March 26, 1888, the task was completed and the first platform was in place. But don't celebrate yet. Eiffel and his company now had around 1 year until the World's Fair opened in Paris and the construction of the Eiffel Tower would have to be completed. Workers were operating on 12-hour days to complete as much work as quickly as possible. Eiffel noticed that when the men took lunch breaks, they would have to climb down all flights of stairs and ladders to the ground level to sit and enjoy their meal. This took quite a bit of time, and also was tiring for the men to have to physically climb all the way up and down the ladders. To remedy this, Eiffel decided to have a canteen installed on the first platform. When the workmen were ready for lunch, they would descend from their station of work above the first platform and into the canteen, eliminating the need to descend the additional 172 feet down to the ground level, and then have to go back up once lunch was over. In France in 1889, drinking on the job was a serious affliction at many job sites. It was thought of as commonplace. Eiffel decided he would offer the men wine in the canteen at a subsidized price, but at the same time, he banned the sale of hard liquor such as cognac. Although the workmen may have some sips of wine, they would not be getting full-on drunk as they would most likely do with the hard liquor. To help secure men while they worked on the iron columns that traveled up higher and higher, there were also wooden platforms built where the men were working. The iron beam would be shooting higher, and around it would be what looked like a treehouse floor built, with the column protruding up from the center. This helped prevent the men from having to stare straight down from immense heights, which could cause vertigo and have them lose their balance and fall. It also provided a stable structure of support under their feet to reduce the chance of falling. Remember, the workers were out in the open air, hundreds of feet in the sky, and construction continued through all seasons. In the winter, with the bitter cold and wind whipping around, any extra support you could have was greatly appreciated. Work continued at this brisk pace, and the second platform was reached at the start of July 1888. The tower had now reached a height of 380 feet. The canteen for the workers was moved up to the second platform, as close to the current new construction above as it could be. With the second platform completed, Eiffel was proud of his company's progress so far, and invited the French media to a banquet on the first platform. With the press in attendance at the banquet, Eiffel raised his champagne glass and proclaimed in a toast, quote, "Judging by the interest that the tower seems to inspire both in France and abroad, I believe it is fair to say that we are showing the world that France continues to be the leader of progress, and that she is realizing a project which has often been tried or dreamed of. Only through the advancement of science, metallurgy, and the art of engineering that distinguished the latter part of our century have we been able to surpass the generations which preceded us. Construction of this tower will be one of the landmarks of modern industry that made it possible." End quote. In this description straight from Eiffel himself, we have a clear vision of what the construction represented. Although it was a glorious achievement reaching the height of the second platform, there were some problems that arose before this milestone. Shortly after the height of the first platform was reached, there were a few labor disputes. Labor unions had been legalized in France in 1884, and the number of strikes and demands for higher pay and better working conditions and benefits grew substantially. This was 3 years before the start of the construction of the tower. In earlier times, the average number of workplace strikes in France was around 40 per year. Between the years 1886 to 1889, during the time the tower was being built, the average number of strikes went up to 175 per year, a fourfold increase. It seemed inevitable that the tower would run into some type of labor dispute in its time. There was a key deadline in building of the tower, and that was the launch of the World's Fair in May 1889. Since the tower was the grand entrance and gateway to the fair, it was imperative that it was completed on time. The workers knew this, and also knew that it would help in their negotiations. The starting pay rates for the project were between 8 cents to 14 cents an hour, depending on the worker's position and the skill level. In July of 1888, Eiffel raised wages by 1 cent an hour, and then he added accident insurance at the cost of the company instead of as it was before, where it was taken out of workers' pay directly. This change amounted to a 2% increase in salaries. Still, as the tower grew to ever higher heights, worker unrest began to rise as well. The increasing heights made the construction more dangerous, and during the winter months there were issues with the freezing wind. Did you ever see the movie A Christmas Story? One of the iconic scenes in the movie is when a bunch of kids are playing around and one is triple dog dared to touch his tongue to the ice-cold flagpole in the heart of the winter. He does it and then gets his tongue frozen to the pole and can't pull it off. He ends up stuck there crying out for help. A similar occurrence happened to workers on the site when they were placing rivets or laying their hands on the iron framework. Their hands would stick to the metal and be difficult to remove, and this could cause tears in the skin. The workers wanted higher hourly rates. In mid-September, the workers demanded that they all be provided with a raise of 4 cents an hour for all workers on the site. The winter was starting to set in, and since the men were paid by the hour, as the amount of daylight in the day grew shorter, the amount of hours of work also contracted. This, coupled with the added extremes of the temperatures as the days went on, helped drive them into the strike for better wages. Work on the tower came to a halt, and Eiffel and the workers' organized labor union entered into negotiations. At first, Eiffel had been willing to only increase wages 1 cent per hour for just the skilled workmen. If you think about it, the approach made sense, as there was a lot of labor for unskilled positions from the rest of Paris, and the labor in these positions could be more easily replaced than the ones that trained for years for a particular job. After 3 days of intense negotiations, a deal was reached. Eiffel implemented a sliding pay scale that would increase the wages of all workers' pay 1 cent per month up until a total of 4 cents in increases had been achieved. The men accepted this new deal and got back to work on the tower. But it didn't last long. Right around the time when the maximum pay increase of 4 cents an hour was being reached, halfway through December, the workers again began to become agitated. This was going into the coldest part of the year and worst working conditions, and the workers thought that if they were going to continue to try and get the tower completed by the opening of the fair, they should be receiving continued pay increases. Again, the men laid down their tools and halted construction, demanding further pay increases. The demands were given to Eiffel by leaders of the organized labor movement on the tower. This time, Eiffel was not willing to budge on the salaries. Eiffel proclaimed that all men who did not show up and work the next day would be fired. He also said that all of the men who remained on the construction until the very end would receive a bonus check. This strong line in the sand convinced many of the workmen to show up ready to work the next day. The ones that didn't show up were fired, removed from the payroll, and quickly replaced. Eiffel felt that he had already budged once on their demands, and that was even after he had already increased wages slightly, and that this second strike was trying to take advantage of his company and the duress they were in to complete the project on time. Some of the leaders of the strike movements also ended up staying on the job. Eiffel had these leaders' tasks reassigned to work on the remaining parts of the first platform rather than work in the glory at the highest points of the tower breaking into the sky. It was a strong smack at their pride. It was like taking managers at a company and then have them perform the most menial tasks instead of their management duties and keep them away from any major decisions. The fellow workmen also took stabs at these demoted leaders, calling them the nickname Les Indispensables. Eventually, most of them ended up quitting rather than continuing to work under the demeaning conditions. The treatment of the strike may have seemed a bit harsh, but it did work. The rest of the project encountered no additional labor disputes. Keep in mind that this is the time period where a few years later, after this point, there would be the Homestead strike in America. The strike in the US between the Carnegie Steel Company and the steel workers ended with an explosion from a bomb, rioting, and 8 people dead. Although Eiffel made that line in the sand on what he was willing to give up in the negotiations, it was a relatively peaceful solution. That being said, it is more than likely that Eiffel did have a strong respect for his workers, but was constricted by the availability of funds and the threat of not properly completing the project for the fair if he was constantly bogged down by labor strikes. Now that the tower was reaching ever greater heights, a new problem needed to be resolved. On the lower platform, it was easy enough to climb ladders or stairs to reach the elevation. There were 362 steps to make it to the first platform. From this lower platform, there were an additional 381 steps to the second platform. There was then a spiral staircase of 927 steps that went from the second platform to the top, which was only used for the workers. But tourists wanting to reach the top of the tower would require additional accommodations. They would want to be brought to the top of the tower swiftly and not be completely out of breath when they reached the destination. They wanted a method that let them travel higher in comfort out of the wind and the elements. They wanted to avoid having to wait for long periods as people in front of them also made their way to the top and back down. People were going to the World's Fair for enjoyment, not for a workout. This is where the Eiffel Tower's elevators came in. There were a lot of complications with the shape and design of the tower that made adding elevators difficult. The angled piers of the tower meant that an elevator could not be positioned in the much easier, straight, vertical alignments as would be standard in a building. Keep in mind that the entire elevator industry was new, having just started in the mid-1850s, and the best technologies and methods to use were still being debated. Today, we think of the standard elevators in office buildings where there's a system of cables that hold a suspended cabin that moves vertically along a track. For some reason, when I picture an elevator, I think of that movie Speed. If you've seen it, you know what I mean. At the time the tower was being built, this modern system for an elevator that has become ubiquitous was actually not the preferred method of construction. Another style of elevator where a piston or screw would push the elevator up from the bottom to the necessary height to unload passengers was a design mostly used in Europe. This method was considered safer, as the cabin of the elevator was always supported from underneath, preventing it from going tumbling down and smashing into oblivion if there were any mechanical failures. The problem for the Eiffel Tower was twofold. The type of elevators that had support from below were much slower and noisier, and they also required a lot of space under the elevator's foundation. In the case of the Eiffel Tower, the foundation of the piers where the elevators would be added was solid cement and was designed to support the weight of the tower. How would the piston or screw fit into the foundation? Boring a hole to house the piston that was the same length deep as the distance of the elevator had to go up was impractical. From the ground to the first platform, there was also an angle of 54 degrees. And from the first platform to the second, there was an angle of 78 degrees. Would the elevators be able to travel at an angle, or would multiple rides on straight tracks have to be implemented instead? All of these problems were laid out for Eiffel and his own company, and they did not have the expertise in this new business to complete the elevators themselves. They ended up having to outsource the jobs to companies that specialized in these areas. It would have been easier, of course, to just put a big cylinder through the middle of the tower straight up to the top where elevators could be easily positioned. But this would ruin the aesthetic beauty of the entire structure, and Eiffel strongly vetoed this idea. This piece of architecture was not just a building, it was a work of art, and in its very design it was meant to show the pride of France. Cluttering it up with ugly supporting structures to get around a slight architectural problem and at the same time destroy the beautiful magnificence of the tower's design is not something they wanted to go for. Take, for instance, another familiar monument, the Statue of Liberty in New York Harbor. The Roman goddess Libertas that is depicted in this sculpture is holding her right hand up toward the sky, holding a torch. The imagery was specifically created to give the impression that the torch, which is a symbol for enlightenment, is lighting the path to liberty for new arrivals through the harbor. There's a lot of artistic touch that went into this design to inspire all those that see the statue. But what if the design was changed to make it easier to build architecturally? What if Gustave Eiffel didn't help out with plans for creating an inner iron framework to distribute and support the massive weight of the arm extending out from the body, an arm that was covered in heavy copper? Architects could have put separate braces against the outside of the arm to hold it up, but then what kind of imagery would that portray? That instead of boldly holding the torch, the Statue of Liberty's torch, a symbol for the path to enlightenment, would have to be held up by crutches? Or maybe the architects would have settled for laying the arm at the side of the statue's body instead of extended above it. Either of these would have drastically changed the look of the Statue of Liberty and potentially diminished her ability to inspire. Building these monuments is not just about construction. It is about the art and the design behind it. No one builds a monument that they want people to just walk by and ignore. It is there to demand attention. Speaking of design and art, here is another little tidbit for you. Where the piers of the tower meet the first platform, there are arches on each side of the tower linking together the piers with a strong iron framework. They look like the beautiful arches of Roman aqueducts of ancient times. The thing is, these arches don't actually bear the weight load of the structure for the tower. They are only there as a visual aesthetic. The legs of the tower going into the cement foundations actually bear the full force of the weight. The arches were designed to look like they are supporting the weight of the structure because it is visually appealing. A tourist looking up at the tower would be like, "Oh yeah, that looks pretty stable. Look at those arches, just like the Romans." At that time, bridges in Europe also mostly utilized the arch in their design to support weight rather than suspension bridges, which were more common in America. The arch was a familiar and comfortable design in Europe, and that is why it was included on the tower. Well, hello there, everyone. That brings us to the end of part 2 of the Eiffel Tower series. I hope you enjoyed the show so far, but you got another one coming. So check out part 3 when it is released. You can view a few pictures of the tower and its construction on our website, sparkhistory.com, where you can also browse our other episodes. In part 3, we will be going into one of the most important details of the Eiffel Tower, its transportation system. A revolutionary new system was set up to bring people to the top of the tower instead of having tourists struggling to climb the 743 steps to the second platform. The new method would ensure that the only thing that would take tourists' breath away would be the view. But to do all this, it will have to continue the grind to completion. Will the construction project run out of money before it is complete? Will the tower be completed in time for the World's Fair? Will it be an economic flop or a gold mine? All that and more in the next episode. See you next time. Have a great day.